Alright guys, today's goal, the learner will understand logarithmic functions and their graphs. So a quick review. Evaluate the expression without using a calculator. Well, that's like 1 over 6 squared, because remember you move it down to make it positive. If you switch from numerator to denominator, denominator to numerator, it changes the sign. So that would be 1 over 36. The next one. Well, I can change 8 to be 2 to the third. And that's to the 11th over 2 to the 32nd. Well, power to a power you multiply, so you get 2 to the 33rd divided by 2 to the 32nd, so it's 2. Because you subtract, 33 minus 32 is 1. Anything to 0 power equals 1. So it says rewrite as a base raised to a rational number exponent. Remember, rational number. Any number that can be written as the division of two integers. So the first thing I can do here is say 1 over e to the 3 halves. One over e to the 3 halves. Well, I want to move it up, so I go e to the negative 3 halves. That's 10 to the 1/4. There we go. So what you learn about? Inverse of exponential functions. Those are the logs. Common logs, meaning base 10. Natural logarithms, meaning the base e. Graphs of logarithmic functions, measuring sound using decibels. Changing between logarithmic and exponential form. Okay. If x is greater than 0 and b is greater than 0 but does not equal 1, then y equals log base b of x, if and only if b to the y equals x. Another way I like to remember this is the base to an exponent equals a number. So ben, if and only if, it's the log of ben e. So if you think about that, 2 to the third equals 8. That means log base 2 of 8 equals 3. So if I said log base 3 of 9 equals what? Change that. 3 to the x equals 9. So you know 3 to the x equals 3 squared, so x equals 2. Okay? See, these are inverses. They're reflected over the line y equals x. Those are the general graphs. Remember exponential growth and then logs. Okay. So, basic properties. Log base b of 1 equals 0. Because b to the 0 equals 1. Log base b of b equals 1, because if you think about this. Second one, log base 9 of 9 equals something. Well, that means 9 to the x equals 9. So 9 to the x equals 9 to the first, so x equals 1. That's what they're doing here. If you think about log base b, so let's use numbers for the third one here. Log base 3 of 3 squared equals 2. Because if I switch that, you get 3 to the second equals 3 to the second. So 2 equals 2. Okay? And the last one, b to the log base b of x equals x, because they're inverses of each other. So, okay? So what they're doing here, let's look. They have b to the log base b of x equals x. Well, remember, Ben is equal to the log of Benny. So if you think about this, I have log, not lob, log, base b of the number. Well, what was the number here? X equals the exponent. What was the exponent? Log base b of x. Okay? The exponential function is inverse. So, see how you have f of x equals 2 to the x, so the inverse is log base 2 of x. And see how the x and y values simply switch. Okay? Logarithms with base 10 are called common logs. So the common log is written, your calculator uses all common logs. So if I said the log of 100, I know that's 2 because it's like log base 10 of 100 equals some number. 10 to the x equals 100. What is that? 2. 10 squared. And common logarithm's inverse is 10 to some power. Okay? Basic properties. Log of 1 is equal to 0 because if you write it this way, you get 10 to the 0 equals 1. Log base 10 of 10 equals 1. Log base 10 of y equals y, or 10 to the y equals y. And for the same reason before, 10 to the log of x is equal to x, as just like when we went over the other one. So, solve the equation by changing it to exponential form. So first thing I would do, put the base in there. And Ben is equal to the log of Benny. So we have the log of Benny. So Ben, b base to the exponent equals a number, 10 to the 4th, 10,000. There you go. Natural log. Okay. So natural log is written ln. But what it is this. Log base e. Okay? Let x and y be real numbers with x greater than 0. The natural log of 1 equals 0. Because if you think about it, we have log base, natural log, which is log base e. That equals 0. E to the 0 equals something. What does it equal? Well, what's anything to the 0? 1. Okay? Same thing here. Natural log of e is 1. Natural log of e to the y is y. And e to the natural log of x is x. Okay? So here's the difference. The blue is the graph of the log function, the red is the natural log. They're very similar, just slightly different. Okay. Describe how to transform the graph y equals natural log of x into the graph of that. So first we have to, I would write it like this, negative x plus 2, and then we want x to always be positive, so you have to factor out a negative. Oh, that equals. parentheses negative x minus 2. So it was shifted 2 units right and reflected over the x-axis. Nope, not x-axis. It's inside the parentheses there, so it's reflected over the y-axis. Remember, if it was negative h of x, that would mean x-axis, but it's h of negative x, so it's y-axis. Okay? There we go. And there's the graph. See how it's going the other way? Remember, the standard form went like this. Okay? Alright. The level of sound intensity is decibels. Beta equals 10 log I divided by the original I. Okay? Intensity. Where B beta is the number of decimals, I is the sound intensity in watts per meter squared. I naught is always 10 to the negative 12th watts per meter squared. And so you'll have to make sure you copy this down. Make sure you get this down and copy this down, because you will need to know these for class tomorrow. See you then.